Great. So yesterday we finished up just kind of defining sequences and series. Today we're going to talk about a specific type of sequence and series, and these are arithmetic series or sequences. I know it's spelled like arithmetic, but I believe it's pronounced arithmetic. Although if I'm wrong, it's going on YouTube forever, so that'll be great. So in an arithmetic sequence, the difference of consecutive terms is constant. Okay, so we actually saw some of these the last 2 days. We saw the one where we're like, oh, it's increasing by 5, right? Well, that would technically be an arithmetic sequence because it's a constant difference. The constant difference is called the common difference. Okay, we're just going to officially call it the common difference. So example 1 just wants us to identify these arithmetic sequences. So we can do that by looking for a common difference. So the way the book, I'll do it the way the book does it for example A, and then in example B, I'll show you like the quicker way that we'll use later on. So the book says to tell the difference, you're going to take the previous or the next term minus the previous term. So if this was your A1 term, this is your A2, this is your A3, A4, A5, and so on. You can then just take, let me zoom in here. You can take your second term, your A2, minus your A1, which if you plug those in, it's just 1 minus -4. You get that the difference is 5. Then you next compare A3 minus A2, which would be 6 minus 1. And again, you get a difference of 5. Now, you do want to test all of these, even if you get a common difference for the first two. Maybe it'd be a really weird kind of sequence. So you want to make sure you keep testing. So A4 minus A3 would be 11 minus 6, which is 5. And then A5 minus A4, which would be 16 minus 11. And again, that's 5. So since these all match, we are good to say yes. And then we're going to label that our common difference is 5. So on Go Formative, you'll have fill in the blank questions like this. You'll say yes or no. If it is yes, you'll put what the common difference is. If it's no, just say none for the common difference. Any questions about that one? Pretty straightforward. Okay, so the more efficient way that I think normal people would do instead of doing this A2 minus A1 is that you just look at the difference. Your arrows should go this way, right? How would you go from 3 to 5? Add 2. Okay, so this is 2. How would you go from 5 to 9? 4. Okay, so now technically, I told you have to go through all of them if they are the same, but really as soon as you find, in math, as soon as you find a counterexample, you're done. So it's not, so we could go on and you would see that it's not even consistent at all. Well, I mean, it is consistent, but it's not increasing by the same thing. So these are a no, and we would just say no common difference. All right, so the last 2 days, I drove some of you crazy because we were writing these rules for series and sequences, and it was a bit of a brain exercise to figure out what the rules were. You will like today, because if you are someone who likes formulas and just plugging things in and solving from there, this is your day. This is what we're going to do. So this is a special kind of sequence because it has a rule that's in general. We're going to look at this algebra part here. So it says the nth term of an arithmetic sequence with first term A1 and common difference D. So again, this is your common difference. Common difference is represented by A sub n equals A sub 1 plus n minus 1 all times D. So again, this is just like your name of your rule. This will be your first term. This you'll leave as an n in general, but sometimes you might plug in a number here, and we'll see examples like that. Minus 1 times D. So there is an example there, but let's just go ahead and look at an example 2 here. So one of the ways that I'll ask you to find this rule is that I'm going to give you the sequence. So I'm going to give you the list of numbers. So in this case, this is probably our easiest version. I will encourage you to write down the general formula many, many times until it's tattooed into your brain. So it's a sub n equals a1 plus n minus 1 times d. And then we sort of just have to ask ourselves, what do we have? What do we not have? Basically what I need, I have my a1, right? My a1 is right here. And then I need that common difference d. So I have a1. Let's find our d. You can do this again just by drawing those arrows. They should go this way. Otherwise, you're going to have a different common difference. So to go from 4 to 9, what would you do? Add 5. So I'm just going to say positive 5. From 9 to 14, add 5. From 14 to 19. Okay, so we're good. It's definitely arithmetic. So we're just going to plug those in. So I'll say my a1 is 4 plus my n minus 1 times my difference, which was 5. Now it's just algebra. I'm going to put that 5 in. So then I have 4 plus 5n minus 5. Now I'm going to do something a little uncomfortable. Your book does it this way. And I'm not sure why it does it this way, but I want to be consistent with your book. Your book will always put the number before the letter part. I don't know why, but I don't want to change that in case it's something important. So our final answer should be -1 plus 5n. And I know a lot of you aren't going to like that. Sorry. Again, I don't know why your book does it that way. It does it for the series and the sequences. So I just want to be consistent. So this is our rule. And then this actual question wants us to find the rule for the nth term. And then it also wants us to find a sub 15. So our 15th term. So to find that, you would just have a sub 15 equals -1 plus 5 times 15. And I'll let you go through all the math, but you should get 74. Any questions about this one? Not too terrible. I'll do one more. So part B, we have this sequence here. So again, throw down your main rule here. It's a sub n equals a1, your first term, plus n minus 1 times your common difference d. So I have that my first term is going to be 60. And now let's look at the difference. Again, your arrow's going this way. How would you go from 60 to 52? Subtract 8. So I'm going to go ahead and put a -8. The sign will matter. So when I plug these in, my a sub 1 was 60 plus n minus 1 times my d, which is now going to be -8. Oops. We'll go ahead and distribute that -8 in. So it should be 60 plus or minus 60 minus 8n plus 8. So your general rule should be 68 minus 8n. Just so you all know, on Go Formative, for these questions, since there's 2 parts, I did it as a fill in the blank again, which again means you don't have access to that numeric keyboard. So when you type in your rule, you can skip the a sub n part, even though technically that's more correct, but you just put in this part. For the ones where you do have a math keyboard, there is one where it just asks you for the rule. Then you can put the a sub n, but just to be consistent, I also just left it with just the rule too as the final answer, just to not confuse you guys. So then let's find our a15, our 15th term. So it'd be 68 minus 8 times 15. And again, if you don't want to pull out your calculator just yet, you should get -52. Easy, right? Hopefully. Any questions about what we did there? Okay. So our next example, so that's finding the rule when I'm giving you a sequence. That's also just verifying if it is arithmetic or not. So we're going to skip example 3 for today. I want to come back to this one tomorrow. But I thought we might want more practice today with example 4. So this is actually just like example 2, other than that we're not going to find the 15th term here. We're just going to find the rule for this arithmetic sequence, but now we're not given the list. What we're given is just 2 random terms from the list. So this is actually going to tie in a lot of stuff just from like Algebra 1. It's pretty fun. I did not leave you guys enough room. I wanted more room for Gauss's face here, sorry. So right small. But basically what we need to do, if you think about our general formula, it's a sub n equals a sub 1 plus n minus 1 times d. And my issue is that I don't have an a sub 1 and I don't even have a d. So I have nothing that I need and apparently no way to find it. Well, that's not quite true. We do have a way to find it. Our way to find it, and I'll see if you guys spot this, it's from Algebra 1. Let me start this setup first and see if you spot it. So let's start with this A27 first. So I know if I plugged in A27 to this general formula, it'd be a sub 27 equals, and then I would have my A1, which again, I don't know what that is, plus, now instead of my n, if I'm talking about a sub 27, my n is 27, minus 1 times my d. Now there's actually even more that I can plug in. So I'm going to take this to the side now. Go ahead and distribute in, well, so I'm saying distribute in the d. Right here, this is 27 minus 1 is just 26. So I'm going to plug in for my A27. That's going to be 97. So let's go ahead and plug in 97 equals a sub 1, and then it would be plus 26d. Okay, that's the first part. The next part, let's do the same thing, but now instead of a sub 27, let's look at our 8th term, a8. So I would have a1 plus my n now is going to be 8 minus 1 times d. Again, if you just simplify and plug in a8, we know is 21. So I'm going to say 21 equals a1 plus 7d. Does anyone recognize, what does this look like? Yeah, it's a system of equations. And we can just use elimination, okay? So we just made a system of equations. You're going to change the signs on one of them. So I'm going to change my bottom to a minus, minus, and minus. Because that way I can just get rid of those a sub 1s. So 97 minus 21 would be 76. My a's are gone. And then I have 19d. And I'll skip some of the algebra here, but if you divide both sides by 19, you should get 4. D equals 4. So I'm going to circle this. I don't know what your strategy was for systems of equations, but I like to circle my variables once I find them. So we have D now. So now we need to go back and find a sub 1. So you have a choice. You can plug D either into the second equation or into the first. I generally just plug it into the first because I like routine. So I'm going to have 97 equals a1 plus 26 times my 4. So simplifying this, you should get, and I'll let you do all the math, but you should get that a sub 1 is equal to -7. Any questions on how I got that D or the a sub 1? Now this looks back like example 2. We have everything we need to write a rule now. So I'm going to go back to this side. Now I can say, okay, my a sub n is -7, because that's my first term, plus, and now we're back to just talking about n minus 1 times 4. Put your 4 in and just combine like terms. So we should have -7 plus 4n minus 4. So our final answer should be -11 plus 4n. Yeah.
So I just have a question. So if it's written like this, do you want us to do elimination, or when I first saw it, I just did 97 minus 21 and I got 76, and then I just divided that by 27 minus 8. And that just
27 minus 8.
I used
So do you know what you just did?
the same thing. I just didn't have to.
Well, you used the slope formula. Because what this is these are really two lines. I skipped the graphing, but when we graph, our y-axis is a sub n and our x-axis is n. What you just did was you found it with the slope.
So can I just do that as a
Yeah, if you're getting the right answer, I don't care. I love that we're able to use, I love that we're able to use different Algebra 1 tools. So if that's something that you want to do, go for it.
I just subtracted 97 minus 21, and then I just, when you do the 76, so it's 76, and then I subtracted 27 minus